Hello and welcome to this presentation on counting pairs whose sum is less than a given target. Today we will explore both a brute force solution and an optimized solution for this problem. Let's dive in. The problem we are solving today involves an array of integers and a target number. Our task is to find how many pairs of numbers in the array have a sum that is strictly less than the target. This is a common type of problem in algorithm design, and we will discuss the approaches to solving it. Our first approach is a brute force solution. The idea is simple. We check all pairs of elements in the array, and for each pair, we check if their sum is less than the target. While this method is straightforward, we will later see how we can improve its efficiency. Here is the code for the brute force approach. First, we initialize a counter called count to keep track of the number of valid pairs. We then iterate over all pairs of elements in the array. Counting with the brute force code, we check if the sum of the pair is less than the target. If it is, we increment our count. At the end, we return the total count of valid pairs. The time complexity of brute force solution is big O of n squared. This is because for each element we compare it with every other element that comes after it, resulting in quadratic time complexity. While this approach is simple, it may not be efficient for larger areas. Now let's explore the optimized solution. The main idea is to first sort the array and then use two pointers to efficiently count the valid pairs. By doing this, we can reduce the time complexity significantly compared to the brute force method. In this part of the optimized solution, we start by sorting the array. Sorting is the first step to making the two-pointer technique work. After sorting, we initialize two pointers, one at the beginning and one at the end of the array. Next, we move the pointers. If the sum of the elements at the two pointers is less than the target, we know that all pairs from the left pointer to the right pointer are valid. We count those pairs and moving the left pointer to the right. If the sum is not less than the target, we move the right pointer to the left. The time complexity of the optimized solution is big O of n log n. The sorting step takes big O of n log n and the two-pointer traversal takes big O of n. As a result, this approach is much more efficient than the brute force method, especially for larger arrays. Here we compare the brute force and optimized solutions in terms of time and space complexity. The brute force method has a time complexity of big O of n squared, while the optimized solution improves this to big O of n log n. Both approaches have constant space complexity of big O of 1, since we don't need extra space other than a variable. To summarize, the brute force solution is simple but inefficient for larger arrays, with a time complexity of big O of n squared. On the other hand, the optimized solution uses sorting and the two-pointer technique to reduce the time complexity to big O of n log n, making it much more efficient for larger datasets. Understanding these approaches helps us design better algorithms for similar problems. That concludes the presentation. Thank you for your attention.